Alright, so this is my second part of section 1.4. This is actually going to be the third time I'm doing the second part of 1.4. I threw out the first two parts because I didn't like them so well, and I tried to give this beautiful lecture, but I think the beautiful lecture was probably more complicated than what I'm about to do. So we're moving into the calculus part of the section. It says find the instantaneous rate of change of the given at the given value. Sketch your graph to model your answer. You may use a calculator to obtain a graph and find the necessary points. So in the beginning of this section, we were given problems that looked just like this, but they had two x values. I sketched a graph. I found 2 points. I connected the 2 points with a line, and I said that was my average rate of change. In this group of problems, I'm going to do something very similar. I'm going to sketch a graph, and I'm going to find 2 points that are microscopically close to each other and draw the line that I drew in the last section. And let me start number 18 just like I started at the beginning of the section. I'm going to draw a graph of x squared minus 5 to get that going. And I'm going to label x equals 4 because that's definitely going to be an important number. I actually know where the vertex of this is already, but you may not because you don't teach the stuff, so you're not as fluid in looking at parabolas and knowing where vertexes are. So I'm going to graph x squared minus 5. And standard window is probably fine. The vertex is at 0, negative 5. I can just count down on that. And in addition to labeling the point 0, negative 5, I'm going to find the point that has 4 as its x value. So I'm going to go second calc value, type in 4. So I'm going to label the point 411 as well. So I'm going to label the point 0, negative 5, 411, and be done with my calculator for a little bit. So there's my point 0, negative 5. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's the point 411. I'm going to draw my parabola, best I can. So this is the information that's given. I'm given the function, and I'm given a value of x. What I'm asked to do is find the instantaneous rate of change. And what an instantaneous rate of change is, or how you calculate an instantaneous rate of change, is you find the point that's as close to the point that you've drawn as possible. It's not showing up here. So I'm going to draw a point that's essentially microscopically just a trillionth or a gazillionth of a tick away from those. And I'm going to draw the line that connects those 2 points. The instantaneous rate of change is an average rate of change of 2 points that are microscopically close. And I'm going to find those 2 points real quickly, and I'm going to make those points arbitrarily close. So the first point that I found was the point 411. So an instantaneous rate of change is an average rate of change of 2 points that are microscopically close. And unfortunately, I didn't take the time to give you a second value for x, and that was on purpose. The second value for x needs to be arbitrarily close to 4. Maybe just, 4 point, a million zeros and a 1 maybe would be arbitrarily close. But I'm not going to write 4 point, a million zeros and 1 for my next x. For my next x, I'm going to write 4 plus h, and I'm going to use calculus to make this h as close to 0 as I can possibly be, so that my 2 points are going to be so close to each other that I can't distinguish them. So this is where we get into calculus. So I'm finding the average rate of change between 2 points, one point that's a fixed solid point on the graph, and another point that's a movable point, and I want to move that point directly on top of my point and find the slope of the line between those 2 points. So for x equal to 4, my calculator can give me the 11. Or I could have got the 11 by hand. To get the 11 by hand, I just would have went f of 4 equals 4 squared minus 5, which is 16 minus 5, which is 11. To get the y-coordinate of the second point, which is something I'm going to make infinitesimally close to the first point, I can't use my calculator because my calculator wouldn't know what to do with that h. So I'm going to have to do some work off to the side. The x-coordinate of my second point is 4 plus h. So the y-coordinate of my second point is going to be 4 plus h squared minus 5. I don't know how well that's showing up, so I'll pull out a different sheet of paper. All I did is take this x value, plugged it into that function, and now I'm going to do the work. 4 plus h squared is 4 plus h times 4 plus h, and then the minus 5 stays. Now I'm going to FOIL this. Firsts are 4 times 4, which is 16. Outers are 4 times h, which is plus 4h. Inners are 4 times h, which is plus 4h. Lasts are h times h, which is plus h squared. So I get 16 plus 4h plus 4h plus h squared minus 5 for the second point's y-coordinate. I'm just going to write this a little bit nicer. I'm going to write the h squared first. I'm going to combine the 4h's together and get an 8h. And I'm going to combine the 16 and minus 5 and get a plus 11. So the y-coordinate of the second point is going to be h squared plus 8h plus 11. So now I have 2 points. I could definitely find the average rate of change between those 2 points just by going y2 minus y1 over x2 minus x1. The instantaneous rate of change is the average rate of change with the points made as close as they can be to each other as possible, and I can get these points on top of each other if I make that h go to 0. So to get an instantaneous rate of change, it's just finding an average rate of change with a little bit of calculus thrown in, making these points as close as you can to each other by using a limit. So the instantaneous rate of change, I should pull out another sheet of paper. The instantaneous rate of change it's just like an average rate of change, but it has a limit in it. It's finding the slope of the line between those 2 points, but making the second point as close to the first point as possible. If I plugged in 0 for the h's, I'd get 4 plus 0, which is 4. 0 squared plus 8 times 0 plus 11, which is 11. I'd get the point 411. So what I'm doing is I'm finding the average rate of change between 2 points, and I'm using calculus to make these points as close as we can possibly be. So now I'm going to go y2 in the numerator, which is h squared plus 8h plus 11 minus y1, which is minus 11, over x2, which is 4 plus h, minus x1, which is 4. Now I'm going to combine like terms in the numerator. In the numerator, the 11's cancel, and I get the limit as h goes to 0 of h squared plus 8h in the numerator. In the denominator, the 4's cancel, so I get an h. So now I have something that's asking me to find a limit. I might as well plug 0 in and see what happens, because that might give me the limit. So this would equal 0 squared plus 8 times 0 over 0. which is 0 over 0. That's not good. That means the limit likely exists, but I have to do algebra to find the limit. And the algebra is usually factoring and canceling, so I'm going to try to factor and cancel this. So I'm going to come down here and rewrite this as the limit as h goes to 0. In the numerator, I'm going to pull out the common factor of h. So if h times h plus 8 over h. And now the h's are going to cancel. Fraction's going to be gone. I'm going to get the limit as h goes to 0 of h plus 8. I could do that now. Now I'm just going to plug in 0 for h. That's 0 plus 8, which is just 8. So the answer to problem 18, the slope of the line that I drew here, it has a slope of 8 because an average rate of change and an instantaneous rate of change are just slopes of lines. And this is a slope of a line that have 2 points that are microscopically close to each other, and that slope of that line is 8. So the answer to problem 18 is the instantaneous rate of change is 8. Let me show you a way to check this on your calculator. It's a little premature to do, but probably not a bad idea to be able to check all these answers on our calculator. It involves knowing something from the next section that we don't know yet, but heck, I'll just pull it out. So for each of the problems between 17 and 24, I'm going to take the given value of x, use it to get a y, and then my next point is going to have the same starting number for the x, and I'm going to add h to it. Then I'm going to fudge around to get my y's, and then I'm just going to find the slope of the line between those 2 points, and I'm going to use calculus to make those points arbitrarily close by making h go to 0. So for this problem right here, to get this answer of 8, I can simply do this on my calculator. So there's the function. I don't think I see the y equal to 11. Let me make my window a little bit bigger because it doesn't have y equal to 11. So I'm going to jump this y up to 15 to make the graph look a little bit different, but that's okay. To find the instantaneous rate of change at a point, you go second in calc, select option 6 that says dy dx. D kind of means change in y over change in x. D means instantaneous change of y over x. So dy dx means technically it's something called a derivative, but it's the way my calculator finds the instantaneous rate of change. You can see the fraction there, change in y over change in x. I hit enter on this, and then I just typed 4 in for x because 4 is the value that I'm trying to find the instantaneous rate of change at. And then I hit equals, and it magically says dy dx. I hope you can see that. It says 8 right there. So the instantaneous rate of change is 8. So if we were doing your problem, y equals 17, x squared minus 3, I type in x squared minus 3. You want the instantaneous rate of change at x equal to 2. I'd have the function in, I'd graph it, then I'd go second, calc, go down to option 6, dy dx is the instantaneous rate of change feature on my calculator, type in equals, and then I'll type in the number 2, and then hit equals. The answer to your problem number 17, the instantaneous rate of change at x equals 2 is going to be 4. So you'll be able to check all these answers really quickly on your calculator. I won't take an answer with just a number. You got to show me the work. All right, let me move on to number 19, or 18, 20, 20. Obviously, maybe time for me to go home, but I got a little bit more to do here. So for number 20, it wants me to find the instantaneous rate of change. And to find an instantaneous rate of change, I need 2 points that need to be arbitrarily close. My first point is going to be the point -1 comma something. My second point is going to be -1 plus h comma something. Let me get the comma somethings. So for the first one, f of -1 equals 5 minus negative 1 squared. That's 5 minus positive 1. I do exponents first. Negative 1 squared is positive 1. That's 4. So the first point is the point negative 1, 4. And the point that I'm going to make on top of the first point has an x-coordinate of negative 1 plus h, and its y-coordinate I get by changing the x to negative 1 plus h, and I'm going to leave this work in a bracket for now. If I don't put it in a bracket, I can get the right answer, but that minus sign out in front there might mess me up. So I'm doing the negative 1 plus h separate from that minus sign, and then I'll incorporate that minus sign. So I'm going to FOIL. Firsts are negative 1 times negative 1, which is positive 1. Outers are negative 1 times positive h, which is negative 1h. Inners are positive h times negative 1, which is negative 1h. Lasts are h times h, which are plus h squared. So that's going to be 5 minus, and then inside the brackets I'm going to get a positive h squared, minus 1h and minus 1h are minus 2h, and then the plus 1 is a plus 1. Now I'm going to get rid of those brackets that I put in, and I need to change all the signs when I dump the brackets, because there's a minus sign in front of those brackets, which is the same as having a minus sign in front of a parentheses. I'm going to change all the signs, and I'm going to get 5 minus h squared plus 2h minus 1. The 5 minus 1 is going to give me a 4, so it's going to give me negative h squared plus 2h plus 4. So my second point, its y-coordinate is going to be negative h squared plus 2h plus 4. Now I have 2 points, and I could find the average rate of change just by going y2 minus y1 over x2 minus x1. I could change that average rate of change into an instantaneous rate of change by making the h as close to 0 as we can get it. So I'm going to do that now. The instantaneous rate of change, should be able to abbreviate that. Instantaneous rate of change is the limit as I make that h as close to 0 as I can, so I make those 2 points on top of each other, of y2, which is negative h squared plus 2h plus 4, that's y2, minus y1, which is 4, over x2, which is negative 1 plus h, minus x1, which is minus a negative 1. I put that minus from the formula and then a negative 1. I had a double negative there, so I put it in a parentheses. In the numerator, the 4's cancel, and in the denominator, this is really negative 1 plus 1, so the 1's will cancel. So this is going to equal the limit as h approaches 0 of negative h squared plus 2h over h. I should plug the zeros in. If I plug the 0 in the numerator, each of the pieces go to 0. I'd get a 0 in the numerator. I'd also get a 0 in the denominator. I'd get a 0 over 0, and I'd have to go to the factoring and canceling. For each of these instantaneous rate of change problems, we're going to have to factor and cancel. So in the numerator, I'm going to factor out a common factor of an h. When I factor out an h from the negative h squared, I didn't factor out the negative, so the negative's going to stay there. I had 2 h's. I factored one of them out. I'm left with 1 h. The plus sign's going to remain. I took the h away from the 2, so I'm just left with a 2. Now I can cancel the h's, and I get the limit as h goes to 0 of negative h plus 2. And I'm going to plug in 0. Stop writing the limit when I plug in 0. I get negative 0 plus 2. That's just 2. So the answer is the instantaneous rate of change is 2. Now I'm going to slam that graph in here that I'm asked to do, because the problem said to do a graph. So I'm going to graph the function 5 minus x squared. It's not going to be a very good graph, and you can, at this point, we're just going to use our calculator to get the graphs. And I'm going to draw the instantaneous rate of change on there, which is going to be drawing a line on there. Okay, so I need to draw 5 minus x squared. I'm going to borrow my calculator. Y equals clear 5 minus x squared. Zoom standard to get back to a standard window because I think I tweaked the window before. That's the point 0.05. I need to plot that point probably because always when I plot parabolas I like to show the vertex. And the other point I wanted was the point, what was the other point that I just had? Where is it? The point -1, +4 I probably want to draw on there as well. So I'm going to put on this graph the point -1, 4. So there's a 4, there's a -1. This is not the best graph, but it's certainly going to be good enough. So I'm going to draw the parabola in. Oh, gosh, -1 is about there then. Let me start this over on a whole other sheet of paper. I'm really disgusted with how this is going. So on for my graph, I'm going to borrow this. So I need -1 and then 1, 2, 3, 4, 5. If I mark out on this, the vertex is at the point 0.05. I also want to label the point -1, 4. So it looks something like this. Maybe label that point 0.05 like I said I was going to. So now I'm going to draw a point that's infinitely close to that, so almost right on top of that. The instantaneous rate of change, that number, the answer that I just got for this problem is the slope of that line. Let's go ahead and use my calculator to find the slope of that line by going second calc, going down to option 6, dy dx, typing in the number -1 and hitting enter. So the slope of that line is 2. In the next section, or pretty quickly, we're going to call this line a tangent line. A tangent line is a line that essentially only touches the curve at one point, or 2 points that are microscopically close to each other. So that's a good finish for problem 20. So the instantaneous rate of change we did, got that part of the answer, and I drew a picture of what the instantaneous rate of change is. It's the instantaneous rate of change is the slope of the line that connects 2 points that are infinitesimally close to each other, even closer than I had them drawn. So this is your time now. You should pause the video and try to do problem 19. If you can get problem 19 done, then you might be able to do the rest of the section without me. The algebra gets a little bit grungier. Unfortunately, in a calculus class, you just can't avoid grungy algebra. And this is kind of the beginning of the grunge. Especially when I choose negative values for the point. It makes it even harder. So to find an instantaneous rate of change, I'm going to do problem 22. I need to create 2 points. One point's going to be the point -3 comma something. The other point's going to be -3 plus h comma something. And I'm going to make those 2 points arbitrarily close. First point, I'm going to get its y value by just going g of -3. G of -3 is going to equal to -3 squared minus 5 times -3 plus 1. That's going to be 9 plus 15 plus 1. That's 25. So when I go to do this on my calculator, I'm going to have to get my y's get really big, at least up to 25 to see what I need to see. Now I need to do my next y, which is the ugly y. I get g of -3 plus h, which is going to be -3 plus h squared minus 5 times -3 plus h plus 1. So that's going to give me -3 plus h times -3 plus h. I need to do that. For this one, when I go -5 times -3 plus h, I go -5 times -3, which is plus 15. Negative 5 times positive h is negative 5h. I still have the plus 1 over there. Now I'm going to go ahead and FOIL this. Firsts are negative 3 times negative 3, which is positive 9. Outers are negative 3 times positive h, which is negative 3h. Inners are h times negative 3, which is negative 3h. Lasts are h times h, which is h squared. Now I'm going to write it in a nice order and combine like terms. So the h squared is going to just stay first, and then the minus 3h, a minus 3h, and that minus 5h are going to combine together, and they're going to combine together to be a minus 11h. And this 9 plus this 15 plus this 1 are going to give me a plus 25. So the second point that I need, its y coordinate's going to be h squared minus 11h plus 25. So now I have 2 points. I can find the average rate of change by just finding the slope of the line between those 2 points. I can make it an instantaneous rate of change if I take the limit as h goes to 0. So that's what I'm going to do. I'm going to find the limit as h goes to 0 of y2, which is h squared minus 11h plus 25 minus y1, which is 25, over x2, which is negative 3 plus h, minus x1, which is minus a negative 3. This is going to equal to the limit as h goes to 0. In the numerator, the 25's cancel, so you get h squared minus 11h. And in the denominator, this is a negative 3, and that's a positive 3. So it's negative 3 plus 3. The 3's cancel, and you get an h. Start to see a pattern in these things. If I plugged in 0, I'd get 0 over 0. I'd have to factor and cancel anyways. I'm going to factor and cancel real quick here. This is going to be the limit as h goes to 0 of h times h minus 11. The common factor of h in the numerator I factor out. Cancel the h's. You get the limit as h goes to 0 of h minus 11. So I'm going to plug in 0 for h. I get 0 minus 11, which is minus 11. So my answer, and without the graph, the instantaneous rate of change is minus 11. So now I'm going to graph this, and I know that my window has to at least go up to 25 on my y's. I'm going to make my y's go up to like 40 just to be safe. Now I'm going to sketch a graph. I'll find the vertex, which is going to be a fraction on my calculator. Your 21 won't have a fraction vertex. I'm going to label the vertex, and I'm going to label the point negative 325, and I'm going to draw in the instantaneous rate of change line, which is going to have a slope of negative 11. I'm going to check it on my calculator. So my graphing part needs to be done. So for my graph, it's not going to be a very good graph. I know that my graph needs to have the point negative 325. That's where I'm going to draw the extra point and make my line. So somewhere's up here, I'm going to be at 25. So that point has to be on the graph. I'm also going to find the vertex. So I'm going to go y equals, bring this down here, y equals clear, then I get x squared. I can't do t squared. Well, my calculator has a t, but it doesn't mean what you want it to mean. So if I did zoom standard, that's negative 10 to 10 on the x's, negative 10 to 10 on the y's. I need to make my y taller, so I'm going to make my y max up to 30. And that's going to be adequate enough for this particular graph. I can see the vertex. That vertex is a minimum point. Let me find it so I can draw at least the vertex along with the point negative 325. So I'm going to go second calc, choose the minimum feature, trace and get close to the vertex but to the left of it, and hit enter. Continue tracing, get to the right of the vertex and hit enter, and then get as close as you can to the vertex and hit enter a third time. You might have to round. I think it's going to be negative 2.5, negative 5.25 for the vertex. Positive 2.5, negative 5.25. So 1, 2, 3, and then I'm just going to call this positive 2.5, negative 5.25. So this is my parabola. It's not a beautiful drawing, but it's good enough. And then the line that I need to draw, I'm going to draw a point that's basically right on top of that point and then connect them. That line right there is going to have a slope of negative 11. Maybe not the best drawing in the world, but it's good enough for us for now. And let me find the slope of that line real quickly by pulling out my calculator, going second calc, going down to the number 6 dy dx, typing in negative 3 and hitting enter, and it gives me that negative 11 perfectly. So I know that my answer is 100% right. All right, 24. What a lovely, lovely problem. So you should make a stab at 21 now. You might be able to do 23 without me doing 24, but I'll do 24 because it's a little messy. So 24, I need 2 points. Your problem's going to be a lot easier than mine because it has a lovely 0 in there. It's so much nicer than having a 4. So my first point for 24 is going to be 4 comma something. Let me get that something by going h of 4 equals 6 times 4 squared minus 3 times 4 plus 1. I want to do that by hand. So I'm going to go 6 times 4 squared minus 3 times 4 plus 1. 4 comma 85. That's really, so I'm going to have to really press my window when I graph it. I'll probably make my y max 100. And then my next point is going to be 4 plus h comma something. And I get that by finding h of 4 plus h, which is going to be 6 times 4 plus h squared minus 3 times 4 plus h plus 1. That's going to be 6 times 4 plus h times 4 plus h. And then this one, I'm going to go minus 3 times 4 is minus 12. Minus 3 times h is minus 3h plus 1. I'm going to multiply these out before I multiply in the 6. So I'm going to do firsts. 4 times 4 is 16. Outers, 4 times h is 4h. Inners, h times 4 is 4h. Last, h times h is h squared. And then minus 12 minus 3h plus 1. Clear this parentheses. 6 times 16 I think is 96. I'm going to make these an 8h and go 6 times 8h is plus 48h. And then 6 times h squared is plus 6h squared. Minus 12 minus 3h plus 1. All right, the 6h squared I'm going to write first. And then for the h terms, I have a plus 48h minus 3h. That's going to be a plus 45h. And then for the numbers, I get plus 96 minus 12 plus 1. And that's a plus 85. I don't think I left myself enough room to write this. So the second point is going to be 4 plus h, comma, 6h squared plus 45h plus 85. Now I have my 2 points. I'm going to find the instantaneous rate of change. The instantaneous rate of change is just the average rate of change with a limit thrown in. So it's going to be the limit as h goes to 0 of y2, 6h squared plus 45h plus 45h plus 85 minus y1, which is 85, over x2, which is 4 plus h, minus x1, which is 4. So this is going to give me the limit as h goes to 0 of 6h squared plus 45h all over h, because in the 4's cancel in the denominator, 85's cancel in the numerator. Factor out my h and cancel. I get the limit as h goes to 0 of h times 6h plus 45 over h. But I cancel the h's and plug my 0 in to the non-fraction. So it's going to be 6 times 0 plus 45, which is going to be 45. So my answer, the instantaneous rate of change, is 45. That's everything but the graphing part of this. So I'm going to need to graph this, which is going to be a parabola. I'm going to label the vertex, and I'm going to label the point 485, and I'm going to draw the line that I need to draw at the point 485. So now I'm going to use my calculator and do a graph. So on my calculator, I might start off with a small window to make it easier to find my vertex. So I'm going to go 6x squared minus 3x plus 1 and just graph it just enough so hopefully I can see the vertex, and I can. So I'm going to try to find that vertex by going second calc. It's a minimum value. Trace to the left of that vertex and hit enter. Trace to the right of that vertex and hit enter, and get as close as I can to the vertex and hit enter. I think I'm going to round that to 0.25, 0.625. So on my graph, I'm going to draw a vertex at 0.25, comma 0.625, and then I'm going to fudge and get the point 485 shown the best I can. It's not easy to put those on the same graph. When I change the window to make the y's high enough, like make the y up to 100, it starts to really make that vertex look like it's right on the x-axis. But heck, I'll copy that in a second, and let me make sure my answer is right by going second calc option 6 dy dx. I'm going to type in the number 4, and we got 45 for an answer, and certainly the slope of that line is going to be 45. So I'm going to draw a line right there, and the slope of that line is going to be 45. So for my graph, oh gosh, here's 1, there's 1. So 0.25 is a quarter, 0.625 is a little bit more than a half, so that's the point. 0.25, comma 0.625, and then I'm not even going to make it any sort of effort to make the y-axis look like it should. There's 85, here's 4. We'll call that the point 485, even though it really isn't. I'm not looking for perfect graphs, and this one's going to be really hard to make perfect. Have the 2 points labeled that I need to, the vertex and the point of interest, and there's a line that I need to draw. It basically, I make 2 points right next to each other and connect them with a line. All right, so that's the grungy part. Now we're going to get into the word problem part. On the word problem part, I'm going to let you use your calculators to find the instantaneous rate of change, because we've done enough by hand problems finding instantaneous rate of change, and it's just the same process over and over. But I'm going to talk a little bit about what the instantaneous rate of change is giving me. That's more important in the word problems, is to understand what the instantaneous rate of change is giving is going to be more important than actually knowing what the instantaneous rate of change is.